So today we're going to take a look at the stock system of nomenclature, which is an older way of naming compounds. It's still used in different places and you'll see it, so it's still important to understand the stock system. It has been superseded by the IUPAC system, the type 1, type 2, type 3 that we've been going through and doing. Now, the stock system only deals with type 2 compounds, ones where the cation can make more than one possible oxidation state or oxidation number, which means its charge, how many electrons it's lost. For instance, copper can be copper 1 or copper 2. Tin can be tin 2 or tin 4. Good, buddy. Sorry, had to get that tin 4 joke in there. And it's useful because when we go in the next video to name acids, it follows the same naming scheme of adding OUS or IC as the suffix. Now, the stock system goes back to the old name, usually Latin, Greek, or Roman. So, for instance, if we have tin, instead of calling it tin, we would call it stannum. If we had lead, instead of calling it lead, we call it plumbum. We're going to change the ending. Now, your book on page 116, table 5.2, right here, has a whole lot of different type 2 cations in there. And again, you name it exactly the same way as you do any other type 2. The difference is, instead of putting a Roman numeral between the cation name and the anion name, we're going to change the ending depending on what oxidation state it is. So even though they have all of these in your book, I'm only going to hold you responsible for 4 of them. And this sheet you can download off of Google Classroom. It's on there already. The stock system of nomenclature goes back to the old name, usually Latin, and the only 4 elements that I'm going to hold you accountable for are iron, tin, lead, and copper. So iron is ferrum, Fe, Fe5O-Fum. So if it loses 2 electrons, it becomes ferrous. If it loses 3 electrons, it becomes ferric. Tin, stannum. So tin 2 is stan-us, tin 4 is stan-ic. Lead, as I said, is plumbum. So lead 2 is plumbus, and lead 4 is plumbic. Kind of like, oh, you're looking very plumbic today. No, I feel more plumbus. And then copper is cuprum. So we have cuprous and cupric. Copper 1, copper 2. So what we have to do is we have to figure out then which oxidation state we have. And you do that exactly like you did with type 2 naming. You have to look at the anion. From the anion, then you figure out the charge on the cation. So the lower oxidation state is going to change the ending to OUS. So for instance, cuprum becomes cuprous. The higher oxidation number then, copper, would become cupric. So we have cuprum, cuprous, and cupric right there outlined on your sheet. Alright, so let's go through a couple of examples here then, and we can go through and name our compounds. So for instance, if I gave you, oh, what the heck, let's start, since I was saying with the copper, let's have CuSO4. So we follow this just like we did with any of the other type 2 compounds. You have to look at the anion to figure out the charge of the cation. So this is not a binary compound if you are following along the flowcharts in your book. It is a polyatomic ion. So you look on your polyatomic ion sheet and you'll see SO4 is called sulfate, and it has a 2- charge. Well, down here we only have 1 copper, therefore this copper must be 2 positive. And if we named it under IUPAC, it's going to be called copper 2 sulfate. Again, that would be International Union of Pure and Applied Chemistry, naming rules type 2. However, using the stock system, the older system, copper 2 is cupric. So this would be called cupric sulfate. And again, sulfate, you could spell it either F-A-T-E or P-H-A-T-E. And again, this would be in the stock system. You can buy cupric sulfate a lot of farm type stores like Rural King, Big R, Stock and Field, which is what Big R is now, Farm and Fleet. And it's used to put in ponds in order to kill off algae and weeds in there. A lot of pool algicides are copper based, and if you've ever had or know somebody that's had the experience of going swimming in somebody's swimming pool and they had light hair or blonde hair and it turns green, chances are that's due to a copper based algicide that they've been using. So there are other algicides that do not contain copper that they could switch to and avoid that green hair from swimming in the pool. Let's go through another example then. How about PbO2? So PbO2, so we have lead or plumbum and oxygen. So if you have lead, lead is a fairly reactive metal and it oxidizes pretty easily. So we could have PbO and we could have PbO2. In fact, let's go ahead and do both of them. So I'll write PbO up here. So again, we have to look at the cation to figure out what the charge on the cation is. And in this case, we have oxygen in both. Oxygen is always a 2- charge. So oxygen is always a 2- charge. So we have 2 negative here. So therefore, this lead is 2 positive. Here we have 2 times 2 gives me 4 negatives, so I got a grand total of 4 negatives. Since I only have 1 lead, it must be lead 4. So this one is lead 2, this one is lead 4. So looking then at my sheet, I could see lead 2 is plumbus, lead 4 is plumbic. So this one would be called plumbus oxide, and this one would be called plumbic oxide. Now you can go the other way as well. You could be given the name and asked to find the formula, and that's not really that big of a deal. So for instance, stannous fluoride. Now, a really common place that you'll find stannous fluoride is this is the original fluoride that was added to toothpaste to help prevent cavities. Now, most toothpastes now use sodium fluoride instead of stannous fluoride. The problem with stannous fluoride is that it is tin, and if you don't rinse it off your teeth really well, it can react and leave brown stains or residue on your teeth, which will come off when the dental hygienist polishes your teeth, but usually not until then. So that's why they switched from stannous fluoride to sodium fluoride. However, here we have a box of Crest Pro Health Advanced toothpaste. Let me fix the focus a little bit, see if we can get that to focus in a little bit better. And if I flip it over and we look at the active ingredients, it states here stannous fluoride. Now, the school wouldn't buy me a document camera, so I had to get my own. It doesn't have zoom on there. So being, a chemist and a physicist, I have an easy solution: magnifying glass. And so right there we can see that it indeed says stannous fluoride 0.454%, 0.16% weight by volume fluoride ion. And so now what we can do is we can figure out, well, what is the formula for stannous fluoride? So just like we wrote out formulas when we're doing type 1 or type 2, we do it the exact same way here. So StanUs means tin, and it has the symbol SN. Fluoride is fluorine, and it always has a charge of 1 minus. If I get out our periodic table here that we colored in, would be right here. It has to gain 1 electron to get the same number of electrons or be isoelectric with neon. And so fluorine always has a 1 minus charge. And tin, StanUs, means that it is tin 2, so it has a 2 positive charge. So crisscrossing the superscripts, make them subscripts. Again, if there's a 1, you don't write the 1, it's implied that it's there. This becomes SnF2. Whereas opposed to if it was StanIc fluoride. StanIc would be SN4 positive. Fluorine is still 1 minus, so it would be SN4 for StanIc fluoride.